In today's lesson, we've got a bunch more vocabulary to go through before we can continue learning how to find these missing angles. This is going to bring a little bit more complexity to those questions. But before we get there, we need to know what we're talking about. So, the first word that we need to understand is what an adjacent angle is. An adjacent angle is when two angles share a common side, but their interiors do not intersect. Let's take a look at an example of what that looks like and an example of what that does not look like. So, an example of an adjacent angle, or a pair of adjacent angles, is if I have something like this, and let's make our vertex A, I'll have a point B over here, and a point D over here, and I'll have one ray going through here, and let's put point C on this one. So, some adjacent angles in here are BAC and CAD. So I could say that angle BAC is adjacent to angle CAD. Angle CAD. And the word adjacent, that just means the same thing as next to. So angle BAC is next to angle CAD. Angle BAC is adjacent to angle CAD. And that's it. Angle BAC is made right here. DAC, or CAD, they share this side right over here. So these two angles are adjacent. Let's take a look at an example when angles share a side but are not adjacent. So BAC and CAD, they share this red side right here. They can share a side but not be adjacent. Let's take a look at an example of that. So down here, I'm going to draw one more set of angles. Let's see. So something like this with 4 angles going through it. Or rather, 4 rays. All right? And I've got A, V, and ray B, point C, and point D. Now, angles A, V, B, so let me write angle A, V, B, and angle A, V, C, these two share a side. They share AV. But AVC actually has the angle AVB inside of it. If the insides of these angles overlap, then they are not adjacent angles. So angle AVC and AVB are not adjacent because they're not next to each other. Because AVB is inside of, because angle AVB is inside of angle AVC. So adjacent, it just means the same thing as next to, and they need to share a side. Well, in this case, BAC and CAD share a side, and they're next to each other. In our second example here, AVB and AVC, well, AVB is just this part right here. AVC has AVB inside of it. They're not next to each other. AVC has AVB inside of it, so those are not adjacent. That's it for adjacent angles. Let's take a look at a new vocabulary word, vertical angles. So, vertical angles. Vertical angles are pairs of non-adjacent angles formed when two lines intersect. They share a common vertex, but that's it. So let's take a look at what that is. I'm going to use my pencil as a straight edge, and I'm going to draw two lines that intersect. So a line right over here, and then another line right here. Well, vertical angles, and I'll write out these numbers. I'll say angle 1, angle 2, angle 3, and angle 4. Vertical angles are when they share a common vertex, so all of these share a common vertex, but they cannot be adjacent. So 1 and 2, they are adjacent because they share this side right over here. So these aren't vertical. 1 and 4 are adjacent because they share a side right here. But 1 and 3 are not adjacent. So we call angles 1 and 3, these are vertical angles. So angle 1 and angle 3 are vertical. And similarly, likewise, angles 2 and angle 4 are also vertical. So all it means is you have two lines that intersect at a common vertex, and you're just saying the angles that are opposite of each other. Or you could say the angles that are not adjacent. So angle 1 isn't adjacent to 2, isn't adjacent to 4, so its vertical angle is angle 3. Angle 2 is adjacent to 1. Sorry, I think I made a mistake there. Angle 1 is adjacent to 2. Angle 1 is adjacent to 4. So that means it's not vertical with either of those. It's only vertical with the one it's not adjacent to. So 1 and 3 are vertical, and similarly 2 is adjacent to 1, and 2 is adjacent to 3, so it's not vertical with those two, but it does make a vertical angle with angle 4. Now, an example of when that doesn't work out is if I have something like this. If I have a ray this way, a ray this way, a ray this way, and maybe some ray this way. I have a shared vertex, but this is made out of 4 rays instead of 2 lines. In this case, none of these are vertical because it only works out when you have 2 straight lines. Here I have 1, 2, 3, 4 rays, but not 2 straight lines intersecting. These are 4 rays with 1 common vertex. So nothing here is vertical. All right, next definition. We have what is called a linear pair. A linear pair is just when you take, let's write this down. Linear pair. All it is when you take some straight line like this and you draw a ray off of that line. Well, linear has the word line in it. It's a pair of angles that make a line, a linear pair. Pair of angles that make a line. So I have angle 1 here and angle 2 there. Angles 1 and 2 are a linear pair because if I put them together, they'll make a straight line. If I add up this angle and add up that angle, it'll make a straight line. That's all that a linear pair is. Next definition, complementary. So, the word complementary. Complementary angles are angles such that they add up to 90 degrees. So, if I have a 90-degree angle right here, an example of two complementary angles are if I just take a ray and cut it right through here. Well, now I have angle 1 and angle 2. Both of these add up to make a right angle, so I can say that 1 and 2 are complementary to each other. Likewise, if I have something that looks like this, and I tell you that the measure of this angle is 30 degrees, and that the measure of this angle is 60 degrees, well, if I add up these two angles over here, 30 plus 60, that gets me 90 degrees. Well, then it turns out that this angle here and this angle here, these two were complementary angles. Final definition for this lesson is supplementary. Supplementary. So, supplementary angles are just two angles that add up, instead of to 90, they add up to 180. So it is two angles that add up to 180 degrees. 180 we'll find is just a straight line. And so two angles that add up to 180 are supplementary. So let's say right over here I've got 60 degrees, and over here I've got 120 degrees. Well, these two angles are supplementary because 60 plus 120, 120 plus 60 equals 180. Now, if you paid attention, you should realize that a linear pair, because it makes a line pair, that linear pair is always a pair of supplementary angles. I can say that 1 and 2 are supplementary because they make a line. And 180 degrees always makes a straight line. So a linear pair always consists of two supplementary angles.